So we are on the second section, chapter 7. So it says the areas of other quadrilaterals. Well, if it says other quadrilaterals, we must have found the area of some quadrilaterals before today. Put your jacket in your locker, please. It's out of dress code. So, just leave it like that, and then you can have a seat. All right, so we must have found areas of other quadrilaterals, or some quadrilaterals before what we're going to do today. So what were they?
Triangle.
Okay, triangle. It is. It's one of them. And what is the area of a triangle?
Base times height over 2.
Good. Or you could write it with the 1/2 out in front of it. It doesn't really make any difference. It means the same exact thing. Okay. What else did we find the area of before today? Rectangle. All right. So a rectangle. And what is the area of a rectangle?
Base times height.
Good. It's the base times the height. So Tristan's paying attention. Anybody else paying attention? What else do we have a area for? Just off the top of your head. Parallelogram. Parallelogram. And we don't really have to learn anything new for this because it's the same as a rectangle, right? It's the base times the height. But what's really important about the base and the height?
They're multiplied.
Okay, they're multiplied. I mean, that's obvious. It's right in front of us. Yeah, but that's not what I'm looking for. What has to be true about the base and the height?
They're equal.
No, they're perpendicular, right? Right here, the base and the height have to be perpendicular. Anytime you see base and height, the base and the height have to be perpendicular to each other. Okay? Everybody with me on that? So if I had a triangle, all right, I'm just going to draw some random triangle right here. If I call this the base, could I call this side right here the height? Could I call this side right here the height? Why not? They're sides of the triangle. Why can't I call that either one of those the height? Because they're not what? They're not perpendicular. So where would the height be? From the top, perpendicular to the what? The base. The base. So that would be the height right there. Okay, that's what I mean by what's important about the relationship between the base and the height. They've got to be perpendicular to each other. Okay, I think there was one more that we did, wasn't there? Square. All right. Now, if you look at this, 3 of them really have the same formula, don't they? The rectangle, the parallelogram, and the square. Why? Because a rectangle is a what? It's a parallelogram. What is a square? A square is also a what? Parallelogram. So I could write the square area equals what? Base times height. But since a square, all the sides are equal, the base and the height are equal, a lot of times we don't call it the base and the height. Remember, but all the sides are equal. So sometimes they just call it the side, right? Because the side of a rectangle, it doesn't matter which side, does it? It's all the same. So if that's a side, then what's that? Then that's a side. So if I go base times height, I could also say what? The side squared. Side times side, or easier, side squared. Okay? So that's how you see it in the book. We've covered all that stuff, correct? Yes. All right. So now let's do the other quadrilaterals. Well, we've learned other quadrilaterals. We just haven't learned how to find the area of these quadrilaterals. So let's list some other quadrilaterals besides, I was going to say besides what we've done here, but a triangle technically isn't a what? Quadrilateral, all right? But these other ones are rectangle, parallelogram, square. They're all quadrilaterals. So let's, just off the top of our head, can we remember some other quadrilaterals that we've discussed in here before? Trapezoid, that's a good one. A kite is another one. So trapezoid. I heard kite, and then I just heard rhombus. Good. Were there any other ones? No, we already talked about rectangle. Yeah, it's just those 3, and that's what we're going to do today. What? Okay, we're not talking about the homework. We're talking about a new lesson right now. All right, let's stay on topic. So what we're going to do is we're going to find the area of these 3. All right. The nice thing about this is just like we had the same formula for rectangle and parallelogram and basically square, we also have a repeat on a couple of these, and that would be the kite and the rhombus. All right. They actually have the same exact formula. We'll get to it in a second. All right. So that's kind of nice. So you got 3 things, but you really only have to memorize how many? 2 different formulas for these other quadrilaterals. So let's do trapezoid first. All right, so let's draw a trapezoid. Let's see what we can remember about a trapezoid. We'll do it like this and like this. It's not necessarily isosceles. It's just any old trapezoid. What do we call, well, remember, if it was a trapezoid, what's true about this side right here and this side right here? They are what to each other? Say it. I can't hear it. I hear mumbling. Parallel. Okay. Parallel to each other. Good. So we know that they're parallel to each other. The 2 sides that are parallel to each other, we give them names. We call it the what? I think have we talked about this? I think we might have. Yeah, we call this the base, and this would also be a what? A base. But they're 2 different bases, and they're not the same number, are they? So I'm going to call this base 1, and I'm going to call this, take a wild guess, base 7. No, I'm not kidding. Base 2. All right. So base 1 and base 2. Everybody with me on that? Well, what have we talked about just a few minutes ago and in that first section when we talked about bases and areas? What else should we probably want to know? The height, exactly. So where in the world is the height? Is the height that side right there? Is it this side right there? It's down the middle. What does that mean? Down the middle. From there to there, is that down the middle? Okay. Oops, what did I just do? From base to base. I like that. But let's not say straight down, though. Perpendicular from base to base. That's good. I've never said that before. I like it. I'll use it. Okay? So it's perpendicular from base to base. Normally, we would start at a vertex. Okay? It doesn't really matter. I'll show you in a second. Usually, we start at a vertex and we go perpendicular to the base. And I accidentally got rid of that. There we go. All right, so that would be, the height of this trapezoid, okay? Now, there's a bunch of places you could figure out the height. What if you wanted to figure out the height from there? Do we go to there? Do we go to there? Where do we go? Give me a good word. Perpendicular, again, to the base. Would you agree? It doesn't matter where on the base that you start, as long as you go perpendicular to the other base. From what? From base to base. Good. You don't mind if I use that, do you? No, it's okay. All right. All right. And of course, you could have taken it from that vertex. Let's just do it. You could have gone from this vertex perpendicular to the base there. These are all the same exact height, aren't they? Every one of those red lines right there are the same height, and that's the height of the trapezoid. All right. Trapezoid, the word trapezoid, at least it starts off kind of like something what we've done before. What is it? Triangle, right? But this is a trapezoid. Let's think about. I'll just do this. This is not like in the book or anything. This is just me thinking. All right. So here's a triangle. It's not a trapezoid. All right. But what I'm going to do is I'm going to make it a trapezoid. What's an easy way to make this into a trapezoid? Look, I could start anywhere on this side and just draw a line that's what? Parallel, right, to the base of the triangle. And basically, what have you just done? You've basically made, and let's say you cut it off, all right? So you draw a parallel line, and then you cut off the top of that triangle. What did you just make? You just made a trapezoid, didn't you? Okay? You with me? Okay. The triangle had how many bases? Had 1 base. Well, technically, any of the sides could be considered the base as long as the height would be perpendicular to that base. But that triangle right here, that was our base right here, wasn't it? Okay, that was our base. But now we made it into a trapezoid. How many bases does it have? It's got 2. It's got 1 here, and now it's got 1 here. So the area of a triangle is just 1/2. I'll write the word out. The area of the triangle is 1/2 the base times the height, or base times height divided by 2. What do you think the area of I'll just put trap, is that all right? The trapezoid is. It's very, very similar to the area of a triangle, except it's going to be 1/2. How many bases do we have? We have 2 bases. What do you think I'm going to do to those 2 bases? Add them together. I'm going to add them together, all right? So I don't just go 2 times b, because this one and this one are different sizes. Everybody see that? So I can't just say 2b, because I don't know. Remember, this is b1 and this is b2. So what do you think I'm going to write here? 1/2 of what? Instead of base, I'm going to write, come on, you told me already. b1. You just said it. What do you do with the bases? And I agreed with you. You add them. So what would it be? b1 plus b2. Thank you. All right. All I'm doing is just adding the bases together. All right. So there's my 1/2. There's my base. What do I need now? Times the height. That right there is the formula for a trapezoid. It's very, very similar, isn't it, to a triangle? 1/2 the base times the height. Except a trapezoid doesn't have just one base. It's got what? It's got 2 bases. So what am I going to do with those 2 bases? Add them up. Does that make it easy to remember how that formula is? Don't just sit there and say, okay, I got to study for my geometry quiz. Area of a trapezoid. What is it? It's 1/2 b1 plus b2 in parentheses times h. That's not how you memorize it. Memorize it like this. You know what a triangle is. It's 1/2 the base times the height. That's easy. Would you agree? Right. Yeah, you knew that before you walked in this room first day of school. You already knew that. Right? So a trapezoid's really close to a triangle. So instead of 1/2 just the base times the height, it's what? It's just the bases added together times the height. Can you remember that? All right, because you're going to have to. All right? You're going to have to remember the formulas for these things. All right. I did a thing on my notes where I kind of show you how you got the area of this to be this. I'm not going to. Let's just remember it like this, okay? All right.
What does the A represent?
Yeah, it's what we've been. Yeah, you should. I mean, Tim, nobody's judging you. I mean, it's just a matter of these last 2 lessons have all been about area, and to ask what the A stands for is, I don't know, maybe you just weren't paying attention like you should. All right, let's do an example. Now, in this one, I don't know why the book does this, but they do. Usually they give you nice little even numbers, don't they? But life is not full of nice little even numbers. Life has really weird numbers sometimes. So that's what they're going to do. They're saying this is a trapezoid, right? Here's a base, here's a base. And this is 4.25. Now they put inches like this, that little thing right there. Everybody understand that? So this is inches, and just one of them is what? Feet. So if I had 3 that's inches, 3 inches. If I have 3 just a little dash, it's not a 1, it's like a little, oops. Oh man, I'm messing this all up. Let's try this again. Watch. If I have 3 it's kind of like a, what do you call that? Apostrophe kind of thing, like a double apostrophe thing. All right. And that's inches. Okay. So what if I just have 3 and then just one little dash thing right there? What is that? That's 3 what? That's 3 feet. Okay. Just so you know. Yes. Fill out a pass. All right. So this is what? 4.25 what? Inches. And then this one is 3.25 inches. All right. And then they also tell you, I mean, they made this just super basic. They didn't really challenge you on this at all. But they will eventually challenge you. All right, so let's see. They tell you this is 6 inches. And they ask you, what do you think they're going to ask you to find? How about that? The area of this trapezoid. So here's the first thing I would do. Does everybody listen? A lot of conversations going on. Let's everybody focus up here. So they ask you for the area of this thing. First thing I would do, especially when you're first learning these things, is to always write down the formula. Every single time you do a problem, if it's a trapezoid, write down the formula. Don't just plug the numbers into it. Don't just write it at the top of your paper or have it in your notes and refer to it. Write it down at first. Why do you write it down every single time you see a problem with it? And memorize it. That's right. Okay, if you write it down, it's easier to memorize. So let's write it down. What is it? You don't have it up in front of you right now. It's 1/2 what? B1 plus B2, all right, times the height. Exactly. And they ask you to find the area. They say, find the area. That's what they ask you to find. So you write down the formula. This is as simple as an area of a trapezoid problem can get. So watch. It's 1/2 times what? It doesn't matter which one you use as 1 or 2. It makes no difference because you're just adding the two numbers together anyway, right? So it's 4.25 plus what? 3.25, close parentheses, times the height. What's the height of this thing? 7.5? Come on, Tim. Look. It's right there. It's given to you right there. All right. Maybe it's because I didn't put the little box there. Maybe that's what it was. But now it is perpendicular. All right. So what is the height of this thing? It's 6. Everything's in inches, so you're good to go. So just plug all that in a calculator. I'm not going to do it for you, but you get 22.5. Now, this is in inches. Now watch, they put that little symbol, that little dash, those 2 dash things. I'm going to actually put inches. For area, what do we always... It's inches squared. So area equals 22.5 inches, what? Squared. Now, do you square the 22.5? No. People do that. They're wrong, but they do it, okay? So it's inches squared, all right? And that's how you write your answer. It doesn't get much easier than that, all right? I think in the homework problems, I don't think on the examples they do it, but I think on the homework problems, what they're going to do is this. See if you can... I'll tell you what, let's just do one. Let's use the same picture so I don't have to redraw it, okay? Let's just make up some numbers here. What? Yeah. Yeah, you just add these together. Well, you could multiply them by 6 and then divide by 2, or you could take that divided by 2 and multiply it by 6, or you just throw in your calculator. Here's what I would do. If I had to do this by hand and I didn't have a calculator, this is what I would do. I would add those up, and what's that? 7.5, right? 7.5. And then I would go, look, let's do this in our head. That's 7.5, correct? All right, and then let's do half of 6. That's a lot easier than going half of 7.5. Would you agree? Okay, so half of 6 is what? 3. And then I could do this pretty easy. All right, 7.5 times 3. There's a 15. That's 21. That's 22. 1 decimal place. Boom, there it is, 22.5. By the time I would have got my calculator out, taken the cover off, turned it on, punched the buttons in, I would have had that answer before my calculator was out. Would you agree? Yes. All right, so anyway, but you can use a calculator. I'm fine with that. That's how you would do it. Okay, let's do one. I'm making one up now, all right? I don't know if this is going to come out nice and even. I kind of doubt it because I'm not giving it a whole lot of thought. What if I said that that was 3? This was 9, let's just say. And I didn't know the height, but I knew the area. Again, if I sat down for a few minutes, I could probably think of it. But it'll probably come out ugly, but that's okay. Let's say it's 50 square inches. Okay? Everybody with me? And I asked you to find what? Instead of the area, because they told us the area, what do you think I'm going to have to find here? Find the height. So how in the world would you do that? Well, let's plug everything in. All right? What's the area? It's 50, so put 50 equals, what's that? 1/2. Add up the bases. Let's just do that in our head. 9 plus 3, that's 12. Times what? H, which is the height. Agreed? Now, what would you do here? What's half of 12? 6 times the height. equals what? 50. And then do what? Divide it by 6, and whatever that comes out to be. 6/8 or 48, right? Yes?
Yeah.
So that would be 8, and then 50 minus 48 is what? 2/6 or 8 1/3, right? You could do that, or you could just say 8.3. Again, I just picked a number off the top of my head. Didn't come out nice and even, which I didn't think it would, but that would be the height. So the height would be approximately 8.3. Or if you wanted to give an exact answer, what would you give it as? 8 1/3. Okay? Everybody with me? Okay. So that's how you would do it. Now, there could be a time where they just give you one base and you have to find the other base. That might be even a little trickier. You want to try one?
Yeah, you can.
Let's get rid of this. Let's just keep all those numbers the same. And what do we say this was? 8.3. All right, we'll just use those numbers. Let's just see. And let's say we don't know that one. All right, we'll call it B for base. Okay? So what would you do? Well, you'd put it into your little formula, wouldn't you? A, so what is A? 50 equals 1/2 times B1 plus B2. Well, I don't know that B, so I'll just call it B, plus, you know the other B, which is what? 3, and then times the height, which is 8.3. Now, again, this is going to be kind of tricky because the decimals, but that's okay. Here's what I would do first. Here's a little, I don't know if it's a trick, but it's a good method to do this. Do you see how you have 3 things all being multiplied together? Let's do this to make it a little bit easier for us. Let's get rid of that 1/2 before we do anything. I'm not going to distribute the 1/2. It's going to make it too hard. So now, what do you think? You were stretching. Thought you were enthusiastically trying to answer my question. Nah, don't do that because you got the B over here on the right. I don't want to move everything over here. Let's get rid of the 1/2. How can I get rid of a 1/2? Divide it? Yeah. Technically, you could divide by a half. That's true. But do I want to go 50 divided by a half? I mean, I could. It would work. But what's a lot easier way? Instead of dividing by 1/2, we could multiply by a 2. Watch. If I multiply this by a 2, what happens to the 1/2? Cancels out. If I multiply this side by 2, what can I do over here? Multiply that. So 50 divided by a half is exactly the same thing as 50 times 2. All right? It's the same exact thing. So what would this be? 100 equals, right? That canceled out. Makes it a little bit nicer, doesn't it? Now, this is going to be kind of gross, right? But what I could do is I could divide everything by, what do you think? 8.3, because that's being multiplied. So divide that by 8.3. That cancels. And now, one more step, and I basically have B by itself. How could I get B by itself? Subtract a 3. So take this ugly number, which you could put into a calculator and be fine, minus what? 3. All right? And then whatever you get. You'll probably get something close to 9. All right? May not be exact because that 8.3 is it's an approximation. So let's do it. 100 divided by 8.3 equals that minus 3. Yep, that's pretty close. 9.048, right? If I just round it to one decimal place, what does it round to? It just rounds to 9, just like it should have been, right? Because it was 9 to begin with. Agreed? All right, enough of that. Let's move on. We got another formula to do. We got 2 more formulas to do. And why don't I have an example? Hold on, let me just see something. I don't think I pulled all the notes out. Oh, there it is. Yeah, I didn't use all my notes. Okay, here we go. We are ready. Oh, come on, guys. Killing me. All right. Some of you guys got to go to the doctor, get your bladder checked or something. I don't know. Or how about go to the bathroom during lunch? Wouldn't that be nice? Yeah. They didn't. Well, tell them Mr. Hamrick says that I have to go to the bathroom during lunch. All right, here we go. What's the next one we're going to do? We're going to do the area of a what? A kite. And you gave it to me in order, and that's exactly what we're doing. So let's draw it. We've talked about kites before. So this time we're going to talk about them again, but this time we're finding the area. I'm not going to try to draw this perfect. I'll try to be fairly close. All right. And what I'm going to do is draw this diagonal as well. Now, it's supposed to be perpendicular, but I didn't draw this one exactly correct. But you get the idea. Use your imagination. That's perpendicular, okay? All right, so what do we call these two lines that go in the middle of that kite? We call them the what of the... Well, they do... This one right here bisects this one. That's true. They are diagonals. Very good, okay? They are diagonals to each other. So... I tell you what, let's color code them. Let's make this one blue. And we'll call this one D1. Why do I call it D1? Why don't I just call it D for diagonal? Why the 1? Because there's two of them, exactly right. Okay? So I'll call the blue one D1, and I'll call the pink one, take a wild guess. D7, that's right. All right, so... The D1 goes all the way from there to there. It's the whole length, okay? Even though I just put it right there, it doesn't mean this little bit here. It means the whole entire thing. Everybody see that? All right. Here's the area of a kite. Very, very easy. And the rhombus is exactly the same thing. So I'll just go really quick. The area of a kite is this. Let's watch. I do have in my notes on how to get this formula, all right, from stuff that we already knew, but we're running out of time. I'm just going to give it to you. And you probably... would not be that impressed. Anyway, there it is. That's the area of a kite. It's very simple. So what do you do with the two diagonals? You multiply them together, then you take what? Take half of it. That's it. All right? Very easy. So let's just make up some numbers. Let's say D1 was, 3. And let's say D2 was 9. Let's go 8. Just so this comes out even. Okay? All right? So how do I find the area of this thing? Say it's in feet. That's in feet. That's in feet. All right? So what is it? It's 1/2 what? What times what? Come on. 3 times 8. 3 times 8. Okay, 3 times 8 or 8 times 3 is what? 24. Take half of that. It's what? It's 12. 12 what? Feet squared. So the area is 12 feet squared. So there you go. There's your little tiny example. Very simple. The example in the book uses different numbers. They use real big numbers. Well, not real big. 43 and 23 instead of 3 and 8. But it's the same idea. All right. I need to move because I only got like 6 minutes left. What did I say was true about the two areas, about the kite? Didn't I tell you? Did I? Yeah, I told you. Yeah, I did. I said that both of these have the same formula. So let's draw a rhombus. And let's kind of make it look more like we look a rhombus-y kind of thing. Does all these sides look even? Pretty close, pretty close. All right. Now, rhombus is also a parallelogram. So if I knew, don't write this down, okay? But, I don't know, you can if you want. What would that red line right there represent? That would represent the height. And then, what if I knew that and that? Oops, I'm going to put B for base. Okay? What if I knew both of those? Could you find the area of this thing without knowing a new formula for the area of a rhombus? Yeah, because a rhombus is a what? It's a parallelogram. And what's the area of a parallelogram? Just give me your homework. So base times height. Would you agree? So if I knew those two things, then I could easily find the area just by going base times height. But what if I didn't know that stuff? What if I just knew the diagonals? Well, I've already given you a huge hint. More than a hint. What did I tell you? What did I tell you about the formula for both this and the kite? They're the same exact thing, aren't they? All right, let's color code them again. All right, we'll go blue. What did I do before? Pink? Pinkish purple, whatever that color is. There you go. Looks pink to me. Does that look pink to you? Yep. All right, so those are my diagonals. So what is the area of this rhombus? How do I find it? Area equals what? 1/2 what? D1, D2. So you multiply the blue and the pink one, right? And divide it by 2, and that's your area of this whole thing. And again, I go through in my notes and I show you why that formula is what it is. It's kind of interesting, but I just don't have time to go through all that stuff. I want to get to this. All right. Remember we did that thing for the trapezoid, and I said, well, what if they told you the area, but they didn't tell you the base, or they didn't tell you the height? We're going to do the same exact thing this time with a rhombus. All right. So on this one, they tell you the blue one is 3, and they tell you, no, I'm sorry. They tell you from here to here. I'm not going to put any letters in here, right? From there to there is 3. Everybody with me on that? All right, so if you wanted, I'll tell you what, let's do it like this. Okay, let's say that makes more sense, doesn't it? And let's say this was 4. Good? Okay. Yeah. This is not what I was thinking, but that's all right. Let's do this anyway. This is straightforward. This is not one of those ones where you have to find the diagonals or anything. Okay, they do ask you to find the area. So find the area. Real simple. Well, kind of. It's a little bit more involved than what we did on the other one. Just a little bit. Because they told you this was 3. So remember, it's 1/2 D1, D2. Is it just 3 times 4? What is it?
6.
It's 6, right. It's a rhombus, so the diagonals are bisected, right? On any parallelogram, the diagonals are bisected. So if this is 3, what's this right here? That's also 3. If that's 4, what's this right here? That's 4. So what are we using? 6 and 8, exactly right. So you got 6 and you've got 8. Make sense? So you got to be careful on what they give you. Just because you see in a 3 and a 4, you got to make sure that you know, is it the whole diagonal or is it only half of the diagonal? This one, they only gave you half the diagonal. So yeah, this is 1/2. 6/8 are what? 48. Half of 48 is 24, and there you go. Whatever the units are, it doesn't give you units, so let's write the word unit in there, and then it's squared. All right. I always like to do this. See, instead of just writing a 24 and just circling it, you definitely should have 24 units squared or inches squared or centimeters squared or whatever. But it's also nice to put what you're finding right before it, okay? I don't mark off for it on a quiz or a test, but you should do this. I believe, because I talked to Mr. Rao about this, I believe that he takes off at least a point or so if you don't put area equals, all right? So if you don't say what it's equal to, like if you're solving for x and you don't say x is 3, and if all you do is put 3 like this, he takes a point off because what are you solving for? You don't know, right? So area equals. A lot of teachers do that. I don't, but a lot of teachers do, so you need to get used to that. All right, enough of that. Let's do... Okay, with all that said right there, I'm going to ask you part B. That's part A. So this is example 3. Oops, example 3A. Example 3B, I ask you to find the height of this thing. Where would the height be? It would be from here, where? To there. Okay, hang on just a second. I need you to just hang on a minute. All right? So, watch. That's the height. Would you agree? How in the world, with the information I gave you already, how can you find the height? Well, what's another way to write the area of a rhombus? Since it's a parallelogram, you could also write it what? Base times what? Height. Oh, you know what? Did we do Pythagorean theorem? Did we? Okay. Did we do 3, 4, 5 triangles? Okay, sorry. Anyway, this right here, we're going to learn it at some other point. We're going to learn that that thing is 5. So how could you find this? You know the area already. What is it? It's 24. Equals the base. What is the base? It's 5 times what? The height. Divide both sides by 5. And it comes out to 24 over 5. And that would be the height right there. 24 over 5. All right. So here's what you're doing. You're doing 1 to 14. So yeah, you're going to turn in 7 1b. And you're going to do, oops, not, what am I doing? 7.72 numbers 1 to 14. I think that's what I gave you on the worksheet, or the lesson plan, isn't it? Is that what I gave you? On the lesson plan. Who's got your lesson plan? Has anybody got the lesson plan? Is it 1 to 14?
Yeah, 1 to 14.
Okay, thank you. Yeah, it's on the lesson plan, so we are on track. One day in, we are on track.
This is what was on Renweb 302. I can show you.
302.
I have the picture.
I don't know page numbers. You got to give me lesson numbers. 7.1b was due today. And then 7.2 is due tomorrow.